All right, today's lesson is going to be on antiderivatives. And indefinite integrals. Now, if I start off with f of x equals 3x squared plus 6, and I ask for the derivative. On the derivative, you bring the 2 down, so that's going to be a 6x, and then the derivative of 6 is going to be 0. So this is the derivative. On this function, if I take the derivative, once again, I'm going to bring the 2 down. That's going to be a 6x, and the derivative of 12 is going to be a 0. Notice that it's the same derivative, but different original functions. So in general, I can say that whatever the constant is, when you take the derivative, it's going to be a 0. So the derivatives will still be the same. So right here, if I have 3x squared plus whatever constant it is, and I take the derivative, it's always going to be a 6x. Now I'm going to go the other way around. So this is new now. We're going to start with the derivative, and we are going to do what's called the antiderivative to go back to the top. So right here, if I start with a 6x, now keep in mind, notice that the power has to go up. So right here, it's a 1. Well, I need it to be a 2. Okay, so basically there is a 1 right there. You just don't see it. So I'm technically adding 1 to the exponent. Now, if you notice, the number 6 turns into the number 3, which meant I took the 6 and I divided it by 2. So here, 6 divided by 2 gives me the 3x to the second power. Now that 6 was just a constant. This is called the antiderivative. Same goes for here. You start off with the 6x. Now it has a power of 1. You just don't see the 1. Now, if you're trying to go back to the original, I'm going to add 1 to the exponent. And then 6 divided by 2 gives me the 3. What I want you to realize is whatever that exponent is what you're dividing by. Whatever the exponent is what you're dividing by. And then I can't forget my constants. Here, I'm going to have a 6 over 2x squared plus c, which is still going to be a 3x squared plus c. So let's do the process of derivatives. When you are taking the derivative, you have to bring the exponent down to the front and multiply. So we bring the exponent to the front and we multiply. So we brought the 2 down to the front. That gave me the 6. And then you decrease the power by 1. So we decrease the exponent by 1. And then the derivative of a constant is going to be 0. Now the process of an antiderivative here, you're basically going reverse, okay? So we're gonna add, so right here, we decrease the exponent by 1. So now I'm going to add the exponent by 1. Then after you add the exponent by 1, right here, you are multiplying by the exponent. So the opposite of multiply is divide. So here, what you're gonna do is you're gonna divide the coefficient by the exponent. And then because the derivative of a constant equals 0, we're always just going to add that plus c. So we are going to add c for the constant. So antiderivative is the same as it's the reverse of the derivative. Now, for this one, we like to illustrate it. Now, this right here is called an integral. That's called an integral. That's the integral symbol. And basically, if you have x to the n of the derivative, now when this right here, these cancel each other out. And what you're basically doing is you're going to add 1 to the exponent. So that's going to be x n plus 1. And then you're going to divide the coefficient by the exponent. So whatever the exponent is, which is n plus 1, I'm going to go and divide by n plus 1. And then I'm going to add a constant at the end. We use integral when we are doing antiderivatives. And now if you notice, the integral and the dx, those basically cancel out. And then that's going to be your original function. So if we are taking the integral of a function, okay, this is called the integrand. The dx is basically the variable of integration. You are taking the derivative of the x variable. Now that's going to equal, I'm going to put a capital F. And the reason why I'm putting a capital F, because that's the original function. Original function, which is the antiderivative. And one thing we cannot forget is the plus c. So whenever you see the integral, it has to have a dx or a dy, whatever you are taking the antiderivative, what variable. It has to have that. And then what you're going to do is whatever the exponent is, you're going to add it by 1. And whatever the exponent is, you're also going to divide by it. And then you're going to add a plus c. Let's get into some formulas here. These are nice just to know them because it will save you time. If you have to take the antiderivative of 0, if you notice, you do not have a variable here. So because you do not have a variable, there's nothing you add 1 to. So this part is gone and you're just left with the c value. So for example, oh, actually, that's it for that one, sorry. Let's say I have the integral of some number k. If you have the integral of some number k, and I'll give you an example, you technically have a number there. So that's actually the number, and that's actually x to the 0 power, because x to the 0 power equals 1. So what I'm going to do here is k is going to be considered a constant. I'm going to add 1 to the exponent. So 0 plus 1 is 1. And whatever the exponent is, I'm going to divide by it plus the constant. And this simplifies to just kx plus c. Let me give you an example. 3 to the dx. Right here. This is going to be the integral of 3x to the 0 dx. So if I add 1 to the exponent, that's going to be x to the 1 power. So I have a 3x to the 1 power over 1 plus c, which the final answer there is 3x plus c. Now think about it. How do you check your answer? Take the derivative. The derivative of 3x is 3. The derivative of constant is 0. So yes, that is correct. Now the reason why here is 0 and you don't have an x, because 0 times anything equals what? 0. And what's the derivative of a constant? The derivative of constant is 0. This is a general formula right here. N represents any power. Either it be a fraction, a negative, anything. It's going to be any power. Actually, -1 is going to be a shortcut. That's actually a rule, and we'll get to that. So right here on the antiderivative, what you're going to do is you're going to take the exponent, which is n, you're going to add 1. And whatever the exponent is, you're going to divide by that. Plus the constant, because remember the derivative constant is 0. So let's do an example. Let's say we have x to the 4th power. If you forget the dx, this is wrong. It has to have the integral with the dx. And no, that's not an s. It's called the integral. So right here, what am I going to do? I'm going to take the 4 and I'm going to add 1. And whatever the exponent is, I'm going to divide by that. Plus the constant. So this is the same as saying x to the 5th over 5 plus the constant. And if you wanted to, you can actually write it as a 1/5 x to the 5th power plus c. These are the same thing. Those are the same. Now we're going to get into the trig ones. On the trig ones, if I asked you for the derivative of cosine x, that is equal to, actually, let's start off with sine x. If I ask you for the derivative of sine x, the derivative is cosine x. Well, guess what? The antiderivative is going the opposite direction. So the antiderivative of cosine x dx is going to be a positive sine x plus the constant. If I ask you for the derivative of cosine x, that is actually a negative sine x. Okay, it's really not going to ask that much for a negative sine x. Instead, it's going to ask you for the derivative of positive, the antiderivative of positive sine x. So because the negative is not on this side, the negative is going to go on the cosine. So the antiderivative of positive sine x is actually going to be a negative cosine x. So just remember that. I always like to write my derivatives and then I'll write my antiderivatives next to it so I don't get them confused with the negatives. Next, we're going to take the derivative of tangent. Well, the derivative of tangent is secant squared x. So now antiderivative, I'm going to go secant squared x is going to equal the tangent x. Secant squared x dx is equal to tangent x plus the constant. Next, we're going to have a cosecant. Cosecant is 1 over sine. And the derivative of cosecant, here we go, is a negative cosecant x cotangent x. And don't say cosecant cotangent. It needs to have an argument. But when I ask you for the antiderivative, I'm not going to put the negative. It's just going to be cosecant x cotangent x. Which means that negative is now going to be on this side, which is going to be a negative cosecant x plus a constant. Next, we're going to have secant x. Secant x is equal to 1 over cosine. And the derivative of secant x is secant x tangent x. So now when I write the antiderivative, I'm going to take the antiderivative of the solution, and it's going to equal the derivative part. So here I'm going to have a secant x tangent x. And don't forget, you have to do dx because these two are what cancels out. And this is going to equal a secant x plus the constant. If you want to check your answer, take the derivative here, and that's what you get. And the derivative constant 0. Last trig one is cotangent x. And the derivative of cotangent is negative cosecant squared x. So when I'm doing the antiderivative, I'm going to put positive cosecant squared x, which means that negative is going to be on this side now. So that's going to be a negative cotangent x. Now we can't forget our special our special derivatives, such as e to the x. The derivative of e to the x is e to the x. So if you're taking the antiderivative of e to the x dx, that is e to the x plus a constant. Next, we have a number raised to a variable. That's like 5 to the x power or 10 to the x power. This is equal to a to the x natural log of a. So basically here, on this one, the way it's going to be written, it's going to be written as the antiderivative of a to the x. So I'm only looking at this part. So what happens with the natural log of a is you technically divide both sides by natural log of a. So this would be a to the x over natural log of a plus c. And then here, the derivative of natural log of x, that's 1 over x. Now, this is the one where I told you that the general function, if it's a -1, x to the -1, that's actually this one. Because what makes the x go to the denominator? A negative exponent. So the antiderivative of 1 over x is natural log of x plus c. We, in AP Calculus AB, we do not do antiderivatives of logarithms, okay? And keep in mind, you cannot take the logarithm of a negative. All right, we're going to start off with some examples. So before I can take the derivative here, I need to rewrite it. The rule that I'm going to be using here is going to be this one, where you add 1 to the exponent, and whatever the exponent is, you divide by the exponent. Before I can do this, so I need to rewrite it. So the denominator is the square root of x. That is actually going to be 2 over x to the 1/2 power. Now, what makes it go to the denominator? What makes it go to the denominator is a negative exponent. Now, back to this right here. If we have a constant, we have a number, that number can actually just go out in the front of the integral. So right here, this number 2 is a constant. I'm going to put 2 in the front. There's my integral. And now instead of the x to the 1/2 being a denominator, I'm going to write it as a numerator. That's x to the negative 1/2. So since 2 is a constant, I'm going to put the 2 in front of the integral. And because that's x to the 1/2 in the denominator, I'm going to put it to the top. And now that's going to be a negative 1/2. Now I'm ready to do my antiderivative. So once again, I'm going to use this rule right here where I'm adding by 1, and then whatever the exponent is, I'm going to divide by it. So here, I'm going to keep the 2. I'm going to have an x. Now, let me grab another pen. Right now, I have a negative 1/2 here. So what I'm going to do is I'm going to add 1 to the exponent. And whatever the exponent is, I'm going to actually divide by that. And then I'm going to add this plus c. Now, when I simplify this, I'm going to have a 2x negative 1/2 plus 1 is going to be a half. Negative 1/2 plus 1, that's going to be a half. And if you know your fractions, 2 divided by a half, the 2 flips up to the front, and that's going to become a 4x to the 1/2 plus the constant. Now, how can you check your answer? Go ahead and take the derivative. Bring the 1/2 down, so then 4 divided by a half, and then decrease the power. 1/2 minus 1 is going to be a negative a half, which gives you the square root of x in the denominator. So go ahead and check your answer. Now you can write your answer like that, or you can write it like this. 4x to the 1/2 is the square root of x plus c. These are both correct. Let's go ahead and let's do another example. Let's simplify this first. So when I simplify this, that denominator is going to go underneath both terms in the numerator. So this is going to be an x cubed over x squared plus 3 over x squared dx. X cubed over x squared, that's going to be an x plus 3. And then what makes that go into the denominator is a negative 2 power. If you want, you can go ahead and separate these, write that integral and write that integral, or I can just take the straight antiderivative right now. If I take the antiderivative right now, that's actually an x to the 1 power. You just don't see it. So that's going to be an x to the 1 power. Now remember, for antiderivative, you're going to add 1 to the exponent, and whatever the exponent is, I'm going to divide by that. Plus 3 is a constant. Now the power right now is a negative 2. I'm going to go and I'm going to add by 1. And whatever the exponent is, which is negative 2 plus 1, I'm going to divide by it. And I can't forget the plus the constant. So now let's simplify this. That's going to be an x squared over a 2 plus 3. That's going to be x to the negative 1 power over a negative 1. So right here, a positive negative is going to make that a negative. So this is going to be an x squared over 2 minus, the 3 is going to be a numerator, but right here, this x to the negative 1, it's actually going to be a denominator. Oh, I forgot the plus c. And that's your final answer. So right here, you have an x squared over 2. Right there, a positive negative makes that a negative. And then I'm left with 3, and the x to the negative 1 makes that a denominator. All right, let's try this one right here. I'm going to first simplify. Cube root of x, that means x to the 1/3 power. So that is x to the 1/3 power, x minus 4 dx. When you distribute, this has a power 1, you don't see it. You're adding the exponents up. 1/3 plus 1 is actually 4/3. So that's going to be x to the 4/3. And then that's 4 times x to the 1/3, which is going to be a 4x to the 1/3. Now I'm going to go ahead and I'm going to apply my antiderivative. So I'm going to write it as x to the 4/3. Now I'm going to add 1 to the exponent. And whatever that exponent is, I'm going to divide by it. Minus 4 x to the 1/3. Now, whatever the exponent is, I'm going to add 1. So that's 1/3 plus 1. Well, guess what? That goes in the denominator. Plus my constant. 4 thirds plus 1 is 7 thirds. So